Hello, math students. Welcome back to our module on linear equations. This is lesson 26, and it is called Characterization of Parallel Lines. Our goal for today is, today we will discover what it means if lines on a coordinate plane do not intersect. The question that I want you to be thinking about during this lesson is, what is the name of the solution for two lines that never intersect? All right, things to know. So what we are looking for is we are trying to determine if these two linear equations are a system that has a solution or a system that has no solution. And so what we need to do is we need to apply what we have been working on, trying to figure these things out and determine if there is a solution for them. So one of the things that we do when we are working on this is we are trying to compare where they would be graphed on an actual coordinate plane, and we can do that without actually having to graph them by identifying their slope and their y-intercept. So if we want to do that, which is what we want to do, that will help us identify whether they will intersect or not. And so if we have y equals 5/4 x minus 3, then we know for this equation that the slope is 5/4, and we know that the y-intercept is -3. And then for the next one, it's not in slope-intercept form, so I need to put it in slope-intercept form. So if I change this to y equals 5/4 x minus 2, then the slope for this one would be 5/4, and the b would be -2. And so now if we were actually to graph this, then we would have our graph that looks something like this. And on the first one it says 1, 2, 3 is the y-intercept, and then the slope says go up 5 and to the right 4. So I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4. So I'm going to go up 1, 2, 3, 4, 5, 1, 2, 3, 4. And that right there would be where my line gets connected. And so I'm going to go ahead and draw that for you using my ruler, trying to be more prepared as I do the videos. Okay, so let's connect that line. Oh, why didn't it show up? Hold on. Sorry, what happened here? Let's try it again. There we go. Okay, so there's that line right there. We're going to call that L1 for line 1. So there's L1. Okay, now we're going to do line 2, except this time the y-intercept is at -2, so it would sit right here, and it still says go up 5. So here we go. 1, 2, 3, 4, 5 over 4. 1, 2, 3, 4. And so this is where that set of coordinates would go. And so again, let's draw a line comparing that. And so this would be L2. And so we graphed both of the lines, and what do you notice about those two lines? They have the exact same slope, but their y-intercepts are different. And so they will never, because remember lines continue in both directions forever, will they ever intersect? And so the answer is, to this solution right here, or excuse me, to this system right here, we're going to say that there is no solution for intersection, which means the lines are parallel. I can't remember how to spell parallel. Whoops. I don't know. That's what I think they are. I apologize for not remembering how to spell parallel, but it's something like that. Maybe there's no E there. Maybe it's P-A-R-A-L-L-E. I think that looks better, so we'll make that a really fat L. Okay, so basically, when you have the same slope for both, this is line 1, this is line 2, your slopes are exactly the same, but your intercepts are different, then that means that the lines will always move up and over. The slope will be the exact same, but the intercepts are different, so the lines are going to be running next to each other forever, which makes them parallel. So no solution for intersection, the lines are parallel. Okay, well that's good to know. So let's try the next one. Okay, so the next one we have is we have y equals 2/3 x minus 5, so we already know the slope. The slope for this one is 2/3, and your y-intercept is -5, and we'll call this line 1. And then we have to turn this one into slope-intercept form, and so we would have y equals -1/2 x, and then we would have plus 11/8, right? And the reason why we would have -1/2 is because you have to subtract x to the over. Oh, but then we have to multiply everything by a -1, so this would actually be a positive 1/2 x, and this would really be a -11/8. Okay, so now we have for this one, the slope equals a positive 1/2, and the intercept is at -11/8, which if we do the math, that's really 3 3/8 negative. Okay, so that gives us an idea. And now what we have to do, if we do that, is we have to see what the solution will be for this. So again, we're going to draw our coordinate plane, and we're going to say it's around here. So the first one, it says intercept at -5, so 1, 2, 3, 4, 5. There's my y-intercept. The slope says up 2/3, so 1, 2. 1, 2, 3, 4, 5, 6. Okay, so up to 1, 2, 1, 2, 3. So that's where the new point would be. Now we're going to connect those 2 points, creating this line right here, and we're calling that L1. Okay, and now we have to do the second line, L2, so we'll call this one L2. And it says that the y-intercept is at 3, -3/8. So it would be 1, 2, 3, and then 3/8 is almost half, so we'd say it's about here, right? And then it says to go up 1, so we're going to go to 3/8 and over 2, 1, 2. So that would be about here. And so on this one, you connect those 2 lines right there, and it looks like that they did intersect. Let me get this one a little bit more so we can make it a little bit longer. Right. So the point of intersection, if you can see it, is right there. Okay, so this one does have a solution. So we're going to say a solution, and then we just have to tell what the actual point of collision is, which would be somewhere out there. And we can actually figure it out by determining what your x and y would be for that. But now you see that these 2 lines, there is a solution, and let's notice something. The reason why there's a solution, are their slopes the same? Nope. Are their slope-intercept forms the same? Nope. So when you have different slopes and you have different y-intercepts, you're most likely going to come up with a solution to the system. And the solution to the system is the actual point where they intersect. Okay, so that was good to see. All right, now let's try our next one. Neither one of them are in slope-intercept form, so we need to turn both of them into slope-intercept form. So this one would be y equals -1/3 x plus 8. And then this one would be y equals -1/3 x plus 4. Okay, and does everybody see why it would be -1/3 x? Because you have to get the x over on this side, which makes it negative. And then you have to divide everything by 3. And so that's how we would get 1 divided by 3 is 1/3, and 12 divided by 3 is 4. Okay, so now the slope for this guy is -1/3. Your b on this one is 8. That is L1. Your slope on L2 is -1/3, and your b is at 4. Okay, so now we have to draw our last graph, and this time we're going to draw it this way because our intercept is 1, 2, 3, 4, 5, 6, 7, 8. So there's our first line of intercept, and our slope is down 1/3. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. So we're going down 1/3. So that would be 1, 2, 3. So that's where that line would go. So we connect those 2 guys. that. Okay. Sorry for my lines not being perfect. Remember, it would be a lot better with graph paper, but I don't have graph paper. And then this one says the y-intercept is 4, so 1, 2, 3, 4. And it's supposed to go down 1 over 1, 2, 3. So we're going to say it's there. And then we're going to connect these two lines. And so it looks like that. So if we had a perfect graph paper line, what could you say about these two lines? And you're going to say no solution for intersection lines are parallel. Okay, that doesn't look right either. Oh well. Okay, so we learned something very interesting. Slopes are the same, negative 1/3, negative 1/3. Intercepts are different. So I'm gathering by these two examples right here that we did, when your slopes are the same but you have different intercept, your lines are parallel. Slopes are the same, different intercepts. Lines are parallel. If your slopes are different and your intercepts are different, then you will find a solution because they will collide into each other. Okay? So that was kind of fun to decide and figure out what we can learn from that. All right, what did you find out? No solution means that the lines are parallel. I wish I could remember how to spell parallel. We're just going to do that, even though that was bad. Okay, one solution means the lines intersect. Okay, at one point. At one point. Okay, and then write an example of both of these solutions. Okay, so let's say that one of them is y equals 1/2 x plus 3, and y equals 1/2 x plus 10. Because your slopes are the same and your intercepts are different, then we would call this system parallel. Okay, and then for another one, because it says write an example of both types, no solution means they're parallel, one solution means they intersect. So we're going to say y equals 6/7 x minus 3, and we're going to say y equals 1/8 x plus 9. And we would say that these intersect at a point. Intersect at a point. And why do we know that? The slopes are different and the intercepts are different. When your slopes are the same and your intercepts are different, they're parallel. When the slopes are different and the intercepts are different, then that means that your lines intersect. Okay, so that's the new rule that you have learned. When you have a system where the slopes are the same and the intercepts are different, your lines are parallel. When you have two equations in a system where your slopes are different and your intercepts are different, then you have an intersection at a specific point. So that's how you can help decide what you need to know about the system. Okay? What if we had one where we have same slopes and same intercepts? Well, it's going to be the exact same line because everything on it is the same. So that's kind of interesting. Okay. All right, my darlings, let's go back to our goal. Today we will discover what it means if a line and a coordinate plane do not intersect. What does it mean if they do not intersect? It means that the lines are parallel and that there is no solution. What is the name of the solution for two lines that intersect? That never intersect, excuse me. It is a system that is parallel lines. A system with parallel lines where they never intersect. Okay? All right, kiddos, that's all I have for you in this lesson. Talk to you soon. Bye!